Take 3. My phone was having a bit of an issue while trying to do this before. I don't know how, and I don't care. Shut up. Look. The first thing you have to know is this video includes the constantly misunderstood or misrepresented double slit experiment. And the observer. So what's happening in the double slit experiment? Well, basically they're shining a laser or an electron beam at a set of slits that are small enough the electron has no other way to get through except for go through those slits. Sometimes they say that the electron is going through both slits at the same time. This is irrational. In the double slit experiment, if you're sending an electron beam, the electrons have two distinctive properties. First of all, you are sending an electron, a particle that is known to be a monopole magnet or basic dipole magnet, right? It has a positive, it has a negative. Let's say it's the only negative. It's a magnet, okay? It's just a really tiny magnet. That's all it is. So when you have another beam going across the double slit and the electron beam is going this way, the electromagnetic field is the second component of that electron beam. You got the stream of particles and you got the field itself. Okay? Everyone knows you got the little particle and you got the aura around it. There's a reason why electrons go around atoms. It's that electromagnetic field. How it's attracted to the atom, and the electron is also pushing away with its own force. This kind of repulsion is understood, it's normal, everyone gets it. It's what happens when you make a negative magnet field. It's what's happening when you put two fields of like charge towards each other. They repel each other. Because the energy streams are flowing towards the same point, where one is heading in this direction, the other is heading in that direction. They can't both be going in the same direction, so they push away each other. When you turn the magnet so that the one is facing this way, it's flowing that way, and the other one is also flowing that way, it's able to flow through each other. Right? It's like if you have two fans. One of them's blowing one way, one of them's blowing the other way. They constructively or destructively interfere with each other. Now look what you're doing here. You're doing the same thing. You have two beams, and you think that people would understand how to represent this? What's happening in this thing is you have two beams, okay? They are really close to each other physically. Their timing is off, and he says by femtoseconds. How fast is that? That is such a small fragment of time. It's like billionth of a billionth of a second or something. I could look it up. Why don't I look it up? Just to make it very clear, it's 10 to the 15, or 10 with 15 zeros, 1 10 to the 15 zeros of a second. Or a million billionth of a second. That's an incredibly tiny frame of time. I don't know about you, but energy beams going beside each other through this weird reflector idea that they have.
Same sense as with the regular 3D space. When two went through, an interference pattern happened. The only thing different was the time the lasers went through. Oddly enough, when two went through, an interference pattern happened. The emitter, the mirror, and the receiver remained the same. The only found that its frequency had spread out a little bit in the process, but other than that, tin oxide is the stuff they use in most mobile phone screens. They fired a laser at it, and then rapidly changed the material from transparent to reflective and then back again. This left only a slim window, a few femtoseconds, where the laser was reflected. They called this a time slit. They recorded what the laser looked like after it had been reflected.
Why am I not able to
found
affect the
that its
goddamn
frequency had
stream anymore?
spread out a little bit in the process.
Shut up. So, we're talking about a millionth of a billionth of a second. So a fraction of the beam is being reflected. Then they decide to send two beams. Now, what's physically happening to this reflector to make it reflective versus the laser beam will pass right through? What is physically happening to it?
Position of the emitter, the mirror, and the receiver remained the same. The only thing different was the time the lasers went through. Oddly enough, when two went through, an interference pattern happened. This was not an interference pattern in the same sense as with the regular 3D space double-slit experiment, though. This was an interference pattern that had affected the laser's frequency. Certain frequencies of light within the laser faded out, exactly in line with the way intensity faded.
Okay. First of all, the interference pattern here is a reference of the double-slit experiment. That's when the light, the energy, the little packets of energy are individually bouncing in all sorts of directions. They are spreading out. The electromagnetic field interferes with itself because it's going through two separate holes, one here and one there. And that makes a wave set. The wave interference pattern is the electromagnetic field The individual dots make up this pattern. The frequency and severity, how strong, like the way that the beams are closer together in the middle and farther away spread out is all about how they're spreading out in three-dimensional space, like this, instead of going straight up, which is what we expect to happen. But instead he references something like this. That is the frequency of a beam that's going this way. Not expressive of something that's spreading out. This is happening from many sets of dots that are all going to different parts, and over total, it makes this image. Nothing to do with this image whatsoever. This is what we call in the business a complete fabrication. Not only do frequencies not even work like this, they are a sinusoidal wave, meaning they go up and down, and there's a center point where they go up and down. This kind of thing doesn't happen. This kind of thing is like seeing half of the wave, the top half maybe. And it's fine, maybe you can say that, but you still have to understand and explain and say that the bottom half is happening, whatever.
It out in the regular version of the double slit experiment. To visualize
So basically what they did was they see this wave thing about how the frequency can scrunch up, and they say, oh, the imagery looks similar enough. Let's put it up there. People won't question it. Well, I am, because I know better. And anyone else looking at the paper is going to be like, that is not how that works. Why are you saying this? That is not scientific method. That's just misdirection.
Let's draw out this
And it's
experiment
gross.
in regards to time. The time slit experiment can be drawn in a similar way to the double slit experiment, except we are going to need to visualize the change in the experiment over time. To do that, let's create a...
We're going to, instead of using a regular experiment representation, we're going to use something that abstracts the idea into something where it's like, it doesn't actually at all look like this, but trust me on it, this one's happening.
4D graph where space is along the x-axis and time is along the y-axis. This is easy enough to do. It just looks like this. The photon leaves the emitter to the left, hits the time slit, is reflected, and arrives at the receiver. I've drawn this as a continuous line just to make things simpler later, but the idea works just as well either way. Later, a second photon is released from the emitter. It reflects and arrives at the receiver at a slightly later time, represented in how it takes...
Okay. I'm going to assume that the amount of time between beams possibly is still femtosecond.
Place higher up, further into the future on our time graph. If light behaved normally, traveling along at the speed it was supposed to go at, this would be the end of it. Instead, light is interfering with itself. This means it must be traveling along a path that takes it through the other slit as well as its own.
Why? Don't you understand that the electromagnetic spectrum is everywhere? Of course, light is traveling through both slits. Its electromagnetic field, like, directly. We're not talking about particles with the the original double slit experiment, I think, was an electron gun, and it works with the electromagnetic field, which is the aura around the electron, and the electron itself, which is the pellet or particle. Photons are different because they are just the electromagnetic packet.
This is the only way that light could come in with the pattern that we see. And just like in the double slit experiment,
No, it's not
it's
the
likely
only way.
happening
You've
on the
missed
other side of the
something,
slits
clearly.
too. As for why it's frequency and not intensity that's being messed with here, think about the implications of what you might see if light did indeed come in at a different angle like this. Photons come in little packets of waves, as I've previously mentioned. Now,
Yeah.
look at what happens if you change the angle at which those waves arrive. Here's how it normally might look. I've added a black timeline here and have highlighted every time the receiver receives a new peak in the wave.
Right.
Here's what happens when you alter the direction of the wave's arrival. Suddenly, the peaks are coming in much more frequently. The frequency of a wave over time is very much connected to the color we perceive light to be. Lower frequency light is redder in color. Increasing the frequency shifts light's color towards blue. So this color variation makes sense. What makes less sense is what's going on with the paths this light is taking through time. Remember, the straight lines we started with represent the 299,792,458 meters per second that we see light traveling. So
at a billionth of a millionth of a second, we are changing this reflector. And light is traveling at 200 million meters per second. If you want to think about the cross-section of the area that they are having in the reflector, the area in the reflector could be considered to be the tiniest area you can ever consider. So you need to really consider and mention, but you're not, deliberately not. You need to mention the cross-section, the area that these lights are taking place in the actual experiment. No 4D representation is really needed for this, because all you need is like a flip book type idea. One moment this is happening, and then the next moment this other one is happening. And the only way that the first one could possibly affect the other one is it was traveling through time. Or maybe the residual electromagnetic field that was going from the original beam is still there, slightly, because the time steps here are in the order of magnitude of 10 to the 15th of a second. How far does light travel when it's how fast does light travel? Instead of looking at meters per second, look at 1,000th of a meter per second. That's right. 200 billion thousandths of a meter per second. It's the same difference. It's just saying that in these tiny little motions that you're talking about, right? Million, billion, we're working with something going at the speed of 200 billion. So could we go further? Could we go closer with how small this cross section is? I don't know, because they don't say how far, how close these beams are from each other. That's a detail I would love to have because it's pertinent. The true reference of area and speed in meters, if you're talking about a meter per second as a unit, 200 million as a unit, you realize a meter is like huge, right? It's like 3 whole feet, whatever, yardstick type idea. You know, so if you really want to look at light waves, you shouldn't really communicate it in the form of like you could talk about the exact measurements of this reflector, the exact positions of the laser beams, and the exact speed of the beams and the exact speed of the reflector doing this dance that makes it either go straight or reflect. It seems to be doing that thing, and I can't help but think that it's a little bit close. Too close to be like, oh, there has to be some magic time travel stuff going on. I say magic because there's no freaking way.
We say about the photons that are traveling along these paths. For some parts of their journey, they are traveling slower than the speed of light, taking more time to arrive at a destination that's the same distance away. And yet, for other parts of their journey, they are traveling faster than causality ought to allow. From their perspective, they are traveling backwards in time.
Okay.
As a reminder,
the distances here, we're not talking about in this representation is literally for anyone actually trying to understand physically what is happening. This is useless because distance doesn't mean anything in this representation. One of the things you mentioned earlier, you mentioned how the lights seem to only spread out a bit. Ah, God damn it.
Crucial to choose a character you
Shut up.
position of the emitter The mirror and the receiver remained the same. The only thing different was the time the lasers went through. Oddly enough, when two went through, an interference pattern happened. This was not an interference pattern in the same sense as with the regular 3D space double-slit experiment, though. This was an interference pattern that affected the laser's frequency. Certain frequencies of light within the laser faded out, exactly in line with the way intensity faded out in the regular version of the double-slit experiment.
No, it's the original experiment I need to read. Here's a different thing that I noticed. In this part of the video, he talks about the beam going through, and the energy of the beam is going through before the laser itself is going through.
Building before you go inside it, after all. Fortunately, there was a simple explanation that
there's a theory that a light wave could stretch out in its frequency so much that it literally spans a very long distance, even at its regular speed.
saved us from creating.
But let's go back to where we were going with this.
The peaks are coming in much more frequently. The frequency of a wave over time is very much connected to the color we perceive light to be. Lower frequency light
this
is
isn't
redder in
wrong.
color. Increasing the frequency shifts light's color towards blue. So this color variation makes sense. What makes less sense is what's going on with the paths this light is taking through time. Remember, the straight lines we started with represent the 299,792,458 meters per second that we see light traveling. So what can we say about the photons that are traveling along these paths? For some parts of their journey,
there is literally no units of time. You realize there is nothing happening in between the laser emitter, the reflector, and the reflector and the collector. Emitter, reflector, collector. There is no other stuff happening. There is only what happens to the laser beam as it's going through the reflector itself, as the reflector is changing. There was a part where he said that the beam's frequency spread out. It stretched out. It got a bit longer and stuff. An interference pattern means that wouldn't you see less beam once you get there? Instead of what you represented was a more concentrated, two separate frequencies going off at the same time type of deal. And the easy way that works is that one was affected by the reflector while it was at this position, and the other was reflected, it was like just slightly out of its position. That would make more sense, because that would actually change how the frequency goes and changes.
they are traveling slower than the speed of light, taking more time to arrive at a destination that's the same distance away. And yet, for other parts of their journey, they are traveling faster than causality ought to allow. From their perspective, they are traveling backwards in time. As a reminder, these two emitters.
No, I don't even want to indulge this. It does not help. If you want to do a proper time-space diagram stuff, or proper representation of what is happening physically in time, you have to do a slide setup where instead of having this metaphysical idea that doesn't communicate anything to anyone, it doesn't. It really doesn't. What you really need is there is moments, and then shoot, and then blank space, and then moments, and then shoot with the second beam. And what represents the first beam's results, and what represents the second beam's results. You can do that a lot simpler, and it would actually communicate it. This doesn't communicate anything to me. Not just because I don't know how to read it. No, because it doesn't, it literally represents nothing.
On the left are actually the same one, just at different points in time. The same for the receivers on the right. It is a mind-bending result. And yet,
No, it isn't.
according to the results of this experiment performed by a research team at the Imperial College in London, this is what is occurring. The implications of this are startling. Light always travels the path of least time, the route that allows it to arrive at its destination along the path closest to 299 million.
No, you can't say in one part of the video that light travels through a medium, like through air, through a liquid, through a different liquid. You see it going to its destination at what seems to be recorded at fractions slower. Like instead of 290 million, it's going at 280 million or some BS. And you referenced that yourself with previous part of the video with other experiments. So why would you say now that light likes to take the fastest path? Light doesn't like to take anything. It just takes what it's given. So you have to think about it. The only thing that could have effect on the light is the reflector itself, not the path between the emitter and reflector, or the path between the reflector and the collector.
792,458 meters.
I don't care. I don't care about your number. It's irrelevant. I don't know what I'm listening to. Go away.
58 meters per second, the fastest anything in the universe apparently can go.
That's
yet,
not true.
it
We've
seems that
seen
these
things
efforts
go
locate
faster.
Exactly what path that might involve. Light is testing the waters, putting out feelers that check to see if other paths, and seemingly other paths through time itself, might present a more viable solution. These feelers are interfering with photons that travel alongside it, but also with
Wow,
photons
you're
that
good.
travel a little ahead or behind it in time.
No.
To be clear, we never actually detect photons taking any of these other paths. We don't see photons coming in from the future. We never see photons traveling slower than the speed of light, provided there is no supercooling gases providing an explanation for why they slow down. And yet, for interference patterns to occur, to at least some extent, light must be trying out alternative routes through time. Perhaps it's like lightning.
You are literally doing something to the reflector, changing how light is able to move. It's either moving straight or it's being reflected. There are a whole range of whatever is going on in that material that can affect how the light is moving. This is such a big deal for you that you don't understand it. Why?
Testing many different directions to find the optimal
And then you
path for its
romanticize it.
destination
Like,
before
what?
finding the one that works and collapsing down that path in one giant boom, all other feelers vanishing and collapsing. Or perhaps some other phenomenon is at play. Who can say?
Who can say? Anyone looking? anyone thinking about all the variables, like the actual distances involved, the actual motion of whatever this thing is, a double slit. This, however, is some reflecty-doodad. What is it that's making that reflecty-doodad change from being able to let the energy be reflected and letting the energy go straight through? Fascinating to ask that question.
Experiment. I go into more depth on this experiment in my video here. If you haven't watched it already, I really recommend you do so.
Yeah, you said it wrong here
because
too.
you
I'm not
know
gonna
what this
watch
experiment
it
is for the part that comes next.
again. Definitely not again.
This experiment is a fascinating exploration of how light can sometimes behave like a wave and sometimes like a particle. However, in 2023, researchers from the Imperial College figured out a way to separate the slits of this experiment, not in space, but in time. The way they did this was simple. They took a transparent material called indium tin oxide that, under specific conditions, can be made to be reflective. Indium tin oxide is
Specific conditions. What are you doing to the thing? It's not mentioned.
stuff they use in most mobile phone screens. They fired a laser at it, and then rapidly changed the material from transparent to reflective and then back again. This left
Do you want to know how they did that? I would love to know how they did that, and you know what I think they did? An energy burst. Either an electromagnetic or an electrical field induced, which basically in some cases are just the same thing. So all they did was they were like, let's zap this thing, change its properties so that it's able to have the light go either through, or we assume it's discretely just going to go through, or it's going to go and bounce down towards the reflector. There's a big problem with that. Nothing is discrete when you're talking about stuff moving the speed of light and stuff rapidly changing, right? Light is a spread out thing. Oh, there's something about light going backwards and forwards through time, all this stuff. Absolute conjecture, whimsy, nonsense, perpetuated by this person, who I only subscribed in order to be aware of what silly nonsense people are actually thinking. I don't know if he's like alone. I think that unfortunately the community might also, a lot of the community might also believe this kind of jumbo. And it's disgusting because it's not science. Like, I've been researching this stuff for how long? At least 20 years. Legitimately, that's how long I've been working with all sorts of science ideas. Hell, since I was 8, and I'm only 36 now, so it's like, maybe I've been doing it for 30 years. I don't remember. The point is, I've been working on this for a very long time. Ever since I look at any of these scientific videos, especially any of them, they always go back to the double slit experiment and how blowing everyone's minds it is. that there's an interference pattern. When they forget that when it's electron beam, yeah, it's electrons. They are the particle, the little pellet, and they are also the electromagnetic field that is around the pellet. Otherwise, you wouldn't have atoms the way that you have atoms. Electrons are completely known to be the smallest materials out there. They are distinctly, obviously, definitely 100% an little pellet with an electromagnetic field around them. An influence that spreads to the atom, binds it together with it, but also is pushing away everything else. There's a fragment of the electromagnetic field, that flux, that is being pulled in by the protons. And the rest of it is just like, I don't want to touch the protons. Right? They're pulling me in, and I'm like, not exactly going to let myself get that close. Right? So, when we're talking about objects moving as fast as they are, and then you're talking about light and that, we've already done experiments where we have polarizing stuff changing rapidly. Stuff like the rainbow filter stuff, which was amazing. I don't know what it is. Rainbow, freaking rainbow frequency something. They did something recently. It was like, you know what it is. They shot the beam through the tube, and it ended up becoming these different frequencies, which this is a beautiful example of that happening, but not exactly. Where is it? I don't know. I know someone did it. Who was it? Was Veritasium part of it? No, Veritasium was part of it. Let's look at that. How do you spell Veritasium? Hello? Boom! Did you recently do a video talking about light going through a tube of salt and whatever? And how they change the frequency really fast based on the tube's polarity stuff? And also the medium that it went through. What the shit? Where is the video? Yo, am I missing the video? There's no way I'm missing that video. Am I? Where the fuck is it? The problem with science communication. You know it. Where the fuck is it? Did he not make that video with the... Was it on Destin's channel? What the fuck? Okay, whatever. It blows a hole in your theory. I'll... Okay, whatever. Light bending, light bending experiments. Hello, does anyone have this crazy rainbow tube? I sent it to my mom. Maybe I could look through my text and find it there. Look at this interference pattern. It makes so much sense, and it's spreading out. It's nothing to do with whatever he was talking about. I don't understand how people say that stuff. Where is this damn video? I'm not Doppler affected, or whatever you call it. I have seen it. Where? Okay, now you're just getting into Minecraft. Hold on. I'm gonna pause this.
You and I looked at
This
demo
video.
where we shine linearly polarized light through a tube full of sugar water, and we saw how it rather mysteriously results in these colored diagonal stripes. There I walked through the general outline for an explanation, keeping track of what questions still need to be answered.
So this is what happens to light in a medium sometimes, right? I don't know what's happening with your medium, but it's something where the light is changing frequency. You could do proper investigation of that reflector, know that when it's in one phase versus another phase, there's an in-between. There's all sorts of stuff happening in between. Any of this stuff could happen.
Namely, why does sugar water twist the polarization direction of light? Why does that twisting rate depend on the color of the light? And why, even if you understand that this twist is happening, would you see any evidence of it?
Now, the interesting thing that they found out in this was that light seems to have a kind of, or the sugar water seems to have a kind of what they call it has a certain, the sugar water has a certain design in its crystal lattice that the light wants to will easily go through while turning in one direction than it does in the other direction. It'll be reflected and keep on changing as it goes through. It might not, it might be that the different frequencies, the different twisting, right, as they say over here, where is it? I don't know why it's not showing it. Where the hell is it?
Particle influences that of another. For example, one of the first things you learn, say in a high school physics class, is that charges with the same sign tend to repel each other. And the strength.
It's like, you know this stuff. So like in the other video, why don't you explain to any degree that two beams going in the same direction, once they hit the reflector at its different positions, potentially, you get an interference that is so obvious because they are able to head towards each other. So why do they end up with this? It's because the material isn't so distinctly in one position and in another position. There is a transition, and it takes place at a speed that is slower than the speed of light. Not a big surprise there. Or even if it doesn't matter if it's slower than the speed of light, the fact that it is having a transition whatsoever means light will most definitely probably have some interaction with it in one point, and then anywhere in between that change of direction,
In
that
a bit, what I'd like
polarity.
to show is how this index of refraction can be explained by analyzing how the initial light wave shakes all the charges in the material, and how the resulting second-order propagations.
See, this is the thing. The light wave affecting a material. You should understand that is going to happen inside of this. It's got to be a polarizing lens. Doesn't matter. The point is, not only do you represent other stuff that is incorrect about the initial doubles experiment. Not in this video. This video is a fucking awesome piece of genius. This is actually real shit going on. But you screwed up. Astrid.
And then back again.
Like when I look at you, I'm like, you have to be knowing what you're talking about. You have to say it correctly. You have to be doing it right. You're not.
Able to slow down light to an astonishing 61 kilometers per hour by sending it through a cloud of sodium atoms that had been cooled to 1 billionth of a degree above absolute zero.
You're able to make light be freaking, not even moving faster than like a car. We're talking about something that is moving as fast as I don't know. What 40 million times faster than the car? You're going as fast as a car in this.
2 years later, Howe managed to slow down light speed to zero before warming up the cloud and sending it on its way again. You might find that result.
It's interesting to think that there is a type of material that can stop light entirely just because of its solidity. Now, if I were to properly look at that experiment, find out what's happening, I would say it is more likely that the beam of light is being directly reflected back on itself in such a perfect way that you can't even tell that the beams overlapped. But if I were to look at the experiment myself, if I saw that the beams were overlapped, trust me, I'd be able to tell. Or I'd be able to make an experiment to be able to make sure.
Surprising. However, strange things have happened in the opposite direction too. In 2000, researchers at the NEC Research Institute in Princeton, New Jersey,
There's
sent a
literally,
pulse of
I
light
don't
through
want
a cloud
to, I don't.
of cesium atoms. Alarmingly, when they tried to see how quickly
Instead
the
of slowing
pulse
down, it
exited the cloud,
seemed to speed up. It's so simple, it's like, wait a second, hold on. You made a light go through a medium, it went through faster than is normal for light. You were able to slow light down to the point of absolute zero, or whatever. And maybe you actually achieve that. Because, I mean, if the temperature could affect light at all, then clearly it must, or it's being reflected directly back. One of those two is the case, and if you can slow down light, clearly there must be something that can make light be more energetic. This looks like that. The waves going through it far faster than the particles, meaning, wait, is light actually particles? And electromagnetic field? Can we please get a definitive answer on that BS? Because I'm tired of it. Get a real answer. Prove it. Find a way. This looks like it found a way. You were able to have the beam, which is the electromagnetic field, be able to go straight through everything because it's electromagnetic field. It don't give a damn. It's just going to go straight through. Whereas the beam itself was interfered with. The actual light, right?
That it exited before it had entered. While this might appear to mess with causality, how can you leave a building before you go inside it after all? Fortunately, there was a simple explanation that saved us from creating too many paradoxes. Although the light pulse traveled faster than light, the light itself did not. This was more.
Yeah, that's because the frequency, amplitude, whatever else stuff happens. You can induce something with that energy to go through the material. The energy in the material is accepting and like enhancing of that energy, but it can mess with the apparently the photon itself, which is like, wait, that means that the photon is actually a particle with an electromagnetic field also. Couldn't we just say that? Stop being around the bush, stop being weird and mystical about it. Can I please have someone please just do there has to be ways like this where it's like you can find out the electromagnetic field and the light that's able to go through. You realize there are multiple phases of light. It is possible that one of the phases of light, the X-rays, we know X-rays go faster than regular light. Cuss words I want to say right now are through the roof. It's possible the X-rays, which is a part of light, we're able to get through because the shape of the X-rays aren't interfered by the shape of the material. That's a way easier idea. What is your explanation?
An optical illusion than a refutation of Einstein's relativity. Let's take a closer look at a photon of light.
There's no illusion there. Photon of light is not just one packet of one frequency. It is a spectrum of all the different types of frequencies. Light involves all sorts of things, depending on where it's coming from. I had to put that in because I know you'd be on my butt if I didn't say it. So I'm telling you, light can go around in X-rays, it can go around in ultraviolet, it can go around in red, it can go around in blue, it can go around all that all at the same time, right? And it might be that there was energy going through that, and it's part of the light, but the visible spectrum ain't going through yet. No weird like amplitude increasing stuff. Just like less interference for this other stuff, you know? Or it could be that it amplified the X-rays. The point is, if you're not thinking about it in those terms, you're not doing justice to the system. And I hate these commercials. They're pissing me off. I can't sleep. I really don't like these commercials getting in the way all the time.
To find the optimal path for its destination before finding the one that works and collapsing down that path in one giant boom.
Light does not... Lightning... Okay, look, lightning is it is reflecting off of all sorts of different bits and pieces. It is doing whatever it can to get wherever it can in whatever way, and the path is usually already laid out. All the reflections, all of the possible ion trails are there, and then it's suddenly everything else follows that weird thing. That's why it's a flicker of this, and it stays like that for milliseconds at a time, entire seconds sometimes. That same beam of energy is all just, it lights up that one spot the same way.
All other feelers
See that?
and
Keeping its shape for like multiple flashes, there's a reason for that. That's the structure that is available at the moment. That's the structure that it was able to find. Everything else doesn't have the structure needed. When it comes to light, however, it's a bit different. Just a little. This is a little bit different. It's another one of those things where it's like you can't go off messing around with saying one thing when it's actually another. Light is not lightning. Not at all. Can light behave like lightning? I don't think so. Light, like I said, lightning is the electrons and everything else, but also like the material that it's going through. Packets of stuff interfering and interact, on so many different levels. If light was doing that, it's like saying light was going through a liquid that has all sorts of different refraction points. So it's like not liquid, but random crystals, right? It changes its frequency, right? But we're talking about salt or sugar was specifically one type of crystal with a specific shape. What if you had all sorts of different shapes in there? What would the light look like then? That'd be great. But again, it's being affected by something. It's not choosing a path, it's bouncing like a bullet bouncing off of one wall, another wall, another thing. Physical stuff that exists. Has nothing to do about when it was. None of that.
Or perhaps some other phenomenon is at play. Who can say? For now, all we know is that light has proved once again that it doesn't play by anyone's rules. At least, not rules that we can.
problem is, it really doesn't matter how long you've been a physicist. It doesn't matter how long you've been into any type of science or any kind of study. You can look at this, you can understand the variables, and you can say, wait, if you understand the crystal and how light is going to go through that, or if you understand the polarity of something and how that's affected, if you understand the light, the frequency, and the speed of that, and the moment of possible, and the shape of everything as it's doing its transitions and whatever else. Like, why is my face sometimes turning blue and sometimes being yellow? I don't know. Blame the camera. Blame whatever you want to blame on. I don't know. Ain't nothing normal about any of that stuff. Does that mean I'm changing all sorts of different colors as we go along this? I don't know. Doubt it. I'm pretty much stable. But the camera wants to think and focus or be attuned to whatever it thinks is what's actually happening. And as things get brighter or dimmer, it does things, it changes, whatever. It's adjusting. I don't like it. And I'm not mostly bothered with him. I'm bothered with the scientific community that is around this, and the majority of people who are probably going to end up being like, yeah, it makes sense, similar to what he's saying. Coming to the same conclusions. Not using the proper scientific method. Not doing all the due diligence about it. Adding in some idea of, oh, it's time manipulation again. Just like they said time dilation with satellites, which is also fake. But I explained that in a different video. Time dilation does not happen. The effects that look like time dilation is actually just the light being affected by different amounts of distance between it and its target point, and then back again depending on the speed of the object itself, which in the order of 10,000 kilometers an hour starts to actually, affect how all of the things involved in the atomic clock work. And why wouldn't it? If you're going as fast as like Mach 2 or Mach 3, you're going to be feeling yourself pulled against the back of your seat. Why do people gotta get these things wrong? I don't get it. So again, there's no proof of time of light going backwards in time with any of the stuff that he was saying in this video. I know that me possibly, if I could understand if I could understand the time digraphs like that, if it was a proper representation of what was happening, right? The thing that this does is it tricks your mind. It tricks your senses. You end up thinking that they're two separate things when they're actually not. They're close enough together, probably, that the femtosecond isn't a far enough distance of time at all. That's my conclusion. That's my assumption. Stuff happening with that reflector is the main key to all of it. And if it has to do with, if it's a polarized reflector, if it's energy that's making the reflector do its crazy thing, it's like, of course it is. They're not mechanically doing it. They're electronically doing it. With little zaps. Possibly intense zaps. I don't know. But the energy involved with polarizing the lens could also have to do with how that same energy could have an effect on the light. Don't take that out of account or whatever. I don't want to keep talking about this. I already made a comment talking about you don't know crack. There's my comment. The fact is actually aftershock. The energy excited by the area probably doesn't just dissipate as instantaneous. To bounce back to being silent. The noticeable if you use a foil, the length of time after it hit the foil remains effective is the duration of it, of the aftershock. That's a slightly different theory than what I just talked about. I'm still not wrong. The energy when you shine a light at an object, like they said in other video, that electromagnetic field makes the object itself wiggle. Wouldn't it make sense also that the object's wiggle would retain a bit and it would have to take some time to turn back to normal? And there might be some residual whatever going on, especially at time frames so small as femtoseconds. Please don't give me that. I don't want to hear that stuff. You're like, yeah, it's super close and tight knit and like near each other in time. That it's like, yeah, 2 billionths of a millionth of a sec, or 2 millionths of a billionth of a second. Million billion. That's all I can think of. I can't think of like trillion. What is it? Quadrillion? 2 quadrillionths of a second. That's how it is. And you're saying that's fast enough that it actually won't interfere. It's like that is such a tiny amount of time. It is almost definite that it's going to interfere. What you want is time frames where it's like it's actually longer than that, so that they're nowhere near each other. But we're talking about literally forcing them to collide. And then you wonder why it's collided. Please. It's like if you two shoot the two bullets out of a gun in the same direction, and pretty much. And you're wondering why, like, the wake from the one bullet made the other bullet also feel a wake from the air resistance and whatever. But instead of that, it's the electromagnetic field from the both things going like boom, and it does its thing, pushing it outwards a little bit. I don't know, man. I made private the original attempts of doing this because my phone being crashing or whatever else, I wanted to make sure it was said all in one straight thing as I usually do, and this time it worked, so whatever. Like, I had to restart my phone because it was doing some crazy bullshit. I don't know what was going on, but it doesn't matter. Point is, once again, double slit experiment misrepresented. This new experiment, again, the space-time digraph does not help. The extra distance and whatever else, you cannot assume some weird distance between whatever is happening. It's only happening at the reflector. I could say this in like small packets with a script in a better way. You know what I'm saying? is something that it's like I'm not only trying to understand it myself and make sure I'm saying it properly and make sure I'm understanding exactly what's going on. Like, I'm sure you do that when you're trying to make these videos. It's like, wait, you actually do that? But you're used to these methods. You're used to these other things. You go through the motions, and I go through my motions, and it's similar. Once you're on your path, then it's like you know you're going to say it in a certain way. It doesn't really change the way you perceive it. But, like, literally, I consider the idea of the light doing stuff, and I think about what it's doing to the object. I think about what it's doing possibly to the other beam. Like, you guys are just two beams going on its own. Forget about the reflector. What do they do on their own? Do you mention that? No, you don't. You don't even mention that. That's gross. It's like two beams not going to a reflector. What did they do? You don't say. You don't even go into saying what they normally do. There's no control there. Right? I thought scientific method had control like that. Control is not one beam. Control is two beams, no reflector. What do they do? Where do they hit normally? And then you add the reflector. And you compare the one to the other, and you know then what's happening as the reflector is introduced to the scenario. And it can only happen if it's going backwards in time, and I'm like, hell no! If that's the only thing, again, extraordinary accusations need some proper evidence. You know how it was said. Why do I always gotta say it the same way? The only thing I can say about this video is, okay, you said there's this new experiment, they did a thing, and it seems to show that we have two frequencies ended up coming out from what seems to be both two regular, same frequency, but we end up with two frequencies on the other end, so something must be happening to them somewhere along the line. The only place it could have happened is at the reflector. No one's just going to dispute that. No one's going to say it happened somewhere elsewhere, some time traveling BS. None of that. Just none of that. So, yeah. It'd be interesting. What I would love to see is if you could make a frequency of light that goes and spreads out like you see here. You could have it so that every other person's hand is going up and down. That frequency is going fast AF. Right? Each individual packet, those jolts are faster than you would ever expect. Right? But what if you had a frequency that was so long that it basically was the full duration, the full length? Like almost everyone's hands are up except for one person at the one end, one person at the other end. The length, the height, and the trot for that is like so big, right? The moment it goes through one place, it ends up on affecting the other place. X-rays. Moving on. Toodles. Check out the playlist. Assignments me. Got all sorts of stuff talking about science. I try to make sure people understand what the hell is actually going on, because too many times they're all like, oh, it's mystical stuff and whatever, blah. It's like, no, it ain't. You can explain the shit out of that.